when you look at a digital screen, it just, it looks like a solid, smooth image, right?
Yeah, like a seamless continuum of color.
Exactly. But if you walk right up to it, or if you like zoom in close enough, that smooth illusion completely shatters.
It breaks down into millions of tiny, discrete, flickering pixels.
Yeah. And we find it very comforting to ignore those pixels. I mean, we prefer the illusion of a seamless world because it makes our environment feel predictable, whole.
Oh, absolutely. It's how our brains are wired to survive.
But so what happens if you try to zoom in on reality itself? Because today we are opening a stack of intense, boundary-pushing philosophical and mathematical notes provided by you, the listener.
And it's a massive stack of notes.
It really is. And it essentially tries to prove the universe is pixelated and that the smooth mathematics we've used for centuries to understand it is actually, well, a massive hallucination.
It is a profound set of material, really. The overarching theme in these notes is a radical reframing of reality.
Radical is definitely the word for it.
Yeah, we are looking at a fundamental challenge to how we perceive structure, time, and even the very numbers we use to count.
So, to begin wrapping our heads around how this deep dive dismantles our classical view of reality, we need to start at the ultimate boundary of our universe.
Right.
I'm talking about the speed of light. And there is a strange, almost like mythological role it plays in these notes.
To understand this, we really have to look at the author's striking analogy regarding special relativity. Because in our everyday, classical Newtonian physics, speeds simply add up.
Let me make sure I'm setting the baseline here. So if I'm riding on a train going 50 miles an hour and I throw a baseball forward at 50 miles an hour.
To someone standing on the platform outside?
Right. To them, that ball is moving at 100 miles an hour. It's just basic addition.
Exactly. That is common sense. But light fundamentally refuses to play by those common sense rules.
It's stubborn.
Very. The speed of light in a vacuum, which we represent by the constant c, is roughly 300,000 kilometers per second. And the crazy thing is, it absolutely does not matter how fast you're moving toward a beam of light or away from it.
You will always measure its speed at exactly c.
Always. The source material frames this mathematically pure invariant as well as God.
Wow.
Yeah, it is the single, absolute, unchanging anchor of the entire universe. It never speeds up. It never slows down.
But to keep that constant, to make sure c is always exactly c for every single observer, no matter what they are doing, everything else in the universe has to pay a massive price, don't they?
They really do. And the sources frame this secondary effect, this price, as the devil.
God and the devil.
Right. Because the absolute purity of Tyrkiel is preserved only at the cost of radically relativizing the entire created world.
Explain that a bit more.
Think about the basic equation for speed. Distance divided by time. So if the speed of light is completely locked in stone and you start moving faster and faster, the only way the math still works is if the distance and the time start to break.
Wait, break how? Like literally, physically?
Literally, physically. The universe distorts your reality to protect that absolute speed.
That's terrifying.
It is. As you approach the speed of light, time actually slows down for you compared to someone standing still. The sources call this the devil stealing your seconds.
Stealing your seconds. I love that phrasing.
And it gets weirder. Space itself actually compresses in the direction you are moving. The devil crushing length.
I'm trying to visualize this. It's almost like, I don't know, imagine a massively important VIP walking through a crowded club at an exact, unwavering pace.
Okay, yeah.
They refuse to speed up, they refuse to slow down, and they won't step aside for anyone. So instead, the entire room, the furniture, the walls, the people...
They all have to move.
Right. The room has to warp, shrink, and actively shift out of the way just so that VIP's pace remains absolutely undisturbed.
That is a very vivid way to see it. And objective simultaneity, the idea that two things happen at the same time for everyone, completely dies in this scenario.
Because everyone's clock is ticking differently depending on how fast they're moving out of the VIP's way.
Exactly. What happens simultaneously for you might happen years apart for someone else. The absolute is maintained through a fundamental deception of human intuition.
And according to the notes, this duality gets even more extreme, doesn't it?
Oh, it deepens immensely in general relativity. This is where the geometry of space-time itself starts curving.
Like with gravity.
Yes, it punishes mass with gravity, bending light, and creating black holes where the math gets so twisted that light is actually trapped. But the true collapse happens when we shrink down to the Planck scale.
The ultimate zoom in.
Quantum gravity, yes. At this microscopic level, the notes suggest that the VIP's smooth floor doesn't even exist.
So what's there instead?
Space-time becomes a bubbling, chaotic foam. They call it emergent. The duality of the God absolute and the devil distortion destroys itself because classical, continuous space-time literally ceases to be a thing.
It just vanishes.
Space and time are exposed as just macro illusions built out of discrete bits of quantum information.
Okay, this is a huge pivot point in the material for me. Because if continuous spacetime is just an illusion hiding a pixelated, discrete quantum reality, how do we count those pixels?
That is the big question.
Right. Because the sources take a really hard turn here and argue that our basic math, specifically our reliance on binary code, base 2, is totally flawed for understanding this deeper reality.
They do. The author introduces a concept called the immanence operator.
Immanence operator. Okay.
It's basically a philosophical metric. It's used to measure how much a number system can explain itself without needing an external rulebook to make sense of it. And the notes break this down into 3 regimes of numbers.
Let's walk through those, because honestly, counting feels pretty straightforward until you read this.
All right, well, the first is base 1, or unary. Think of tally marks carved into a wall. 1 mark, 2 marks, 3 marks.
It's like a prisoner counting days on the wall.
Exactly. The source describes this as pure absolute presence. The number physically is the thing it represents.
So 5 tallies means 5 items.
Yeah. It has maximum existential immanence, meaning it just is what it is.
Yeah.
But it has absolutely 0 internal structure. It's incredibly inefficient.
Which naturally leads us to base 2, binary. Just ones and zeros. I mean, this is the bedrock of our modern world.
It is, and here is the author's radical critique. They call binary an ontological minimum.
Ouch.
Yeah. Yes, it's pure information, but they say it possesses absolutely no internal tension. A 1 or a 0 inside a binary string is essentially meaningless on its own.
Because it's just a position.
Right. It only has value if a global external rulebook, an outside interpreter, tells us that the position of that digit doubles its weight.
I see.
We lose the undeniable physical presence of the tally marks, but we gain no living relationship within the digits themselves. It's just a cold, dead switch.
Why?
On or off.
Hold on, I really have to push back on this. Because the author is calling binary dead and poor, but if binary is so ontologically broken, how did it put us on the moon?
Fair point.
Right, like how does it run global banking and the internet you and I use every single day? It feels like a massive conceptual leap to call our most successful technological language fundamentally flawed.
It is a massive leap, but the author is critiquing structure, not utility. Computers are incredibly fast at reading those dead switches, yes.
Okay.
But the sources argue that base 2 simulates numbers rather than manifesting them, because there is no intermediate state between empty, which is 0, and full, which is 1.
So it's just a void or a block, nothing else.
Exactly. There's no dynamic tension inside the number itself. The computer is doing all the heavy lifting externally. This is why the notes heavily champion base 3 or ternary and beyond.
Base 3. So that uses the digits 0, 1, and 2.
Correct. In base 3, the source argues that true mathematical structure is born, because now the digit 2 carries what the author calls dialectical tension.
Let's unpack that. What does dialectical tension actually mean in a physical sense, like a rubber band stretching?
That's a brilliant way to think of it. In base 3, the maximum value a single slot can hold before it spills over is 2.
Right, because when you hit 3, you carry over to the next column.
Exactly.
Yeah.
So when you have a 2 sitting there, it is actively pushing against its own limit. It is one tiny step away from forcing a carryover. It wants to spill over.
Oh, wow. That makes sense.
Yeah. The numbers gain internal relationships. They interact. Binary turns numbers into static code relying on an outside reader, whereas base 3 and above turns numbers into self-organizing structures, vibrating with their own internal tension.
So it's the difference between a light switch that's just on or off versus a pressure valve that is actively building up to a release.
Yes.
That actually changes how I look at counting. And this poverty of structure,
Yeah.
it doesn't just stop at how we use binary, does it? The notes take this exact same logic and use it to attack the bedrock of geometry.
They really go for the throat.
Yeah.
They attack the foundational building block of all classical physics, which is the mathematical point.
The point.
Yeah. If base 2 is an artificial construct lacking internal depth, the sources argue the geometric point is guilty of the exact same crime.
A point, like an XY coordinate on a graph, just a dot.
Yes, but think about what classical physics demands of that dot. We define a mathematical point as having 0 size, 0 internal structure, and taking up 0 duration in time.
Nothing, basically.
Essentially nothing. And yet, physicists will turn around and ask that infinitesimally small non-entity to hold infinite amounts of data.
When you phrase it like that, it sounds absurd. We are treating a mathematically invisible dot like a bottomless hard drive.
We really are.
We ask a location with literally 0 dimensions to hold the precise density of a black hole or the exact vector of a magnetic field.
It is a mathematical magic trick. The sources argue that the concept of the limit, which is the foundational tool of calculus, where you get infinitely close to a value to smooth out a jagged curve, is actually a philosophical hallucination.
Okay, I struggle with calculus, so I'm very happy to call it a hallucination. But what does the author mean by that?
Well, when you use a limit to smooth out a curve, there is always a tiny leftover remainder, a friction.
Like a rounding error.
Kind of. Classical math says, make the step so infinitely small that the remainder basically becomes 0, and then just sweep it under the rug so the equation looks pretty.
Just ignore it.
Right. But the author says sweeping that remainder under the rug is ignoring the actual reality of the universe.
So if space isn't made of a smooth sheet of infinite points, what is it made of?
The alternative is that reality is a crystallization of relations and phases. The listener provided these fascinating diagrams called two-sheet circles.
Oh, yeah. I spent a lot of time looking at those.
Right. Imagine two distinct circular tracks representing discrete layers of reality, sheet 1 and sheet 2. The diagrams list specific parameters, like an n value of 17 or 25, and an incredibly specific phase offset.
That offset was denoted by the Greek letter delta, right? Delta equals 0.891234.
That's the one.
I was staring at these diagrams. There's an inner blue circle and an outer dashed red circle with all these little green and red dots plotted at very specific, staggered angles.
And those dots aren't traditional points in space. They represent discrete phases. Because the two sheets have that phase offset that delta of 0.891234, they are slightly out of sync.
Oh, I see.
So reality isn't a smooth continuum. It is built out of these overlapping layers vibrating against each other.
And the notes push this out into 3 dimensions, too, mapping space as a hexagonal grid.
Yeah. Think of covering a surface with a honeycomb pattern. A central hexagon acts as the base layer. Its 6 sides hold discrete phases, numbered 0 to 5.
Okay, I'm picturing that.
The universe expands outward from there, not through smooth distance, but via graph distances. It's essentially a series of discrete phase transitions clicking together step by step.
It's like viewing reality as an impossibly dense honeycomb of vibrating phases,
Mhm.
constantly clicking against one another. It's beautiful, but I see a massive logistical wall here. Yeah, because if we throw away the smooth continuum, and we refuse to use limits, and we kill the geometric point, how on earth do we actually calculate anything? We still need math to build bridges and launch satellites.
That is the burden of proof for any new theory. If you tear down the foundation, you have to build a new one.
Right.
And the author provides a radical mechanical geometry to calculate the bedrock constants of mathematics, specifically Euler's number, E, and pi.
Euler's number, usually represented as just the letter E, that's the constant used to figure out continuous exponential growth, right?
Yes.
Like compound interest in a bank, or how fast a population of bacteria multiplies. It's always treated as this incredibly abstract, infinite decimal that goes on forever.
Correct. And to calculate it, classical math relies heavily on those limits we just talked about. It tries to smooth out discrete steps of growth into a perfect continuous curve.
Sweeping the remainder under the rug again.
Exactly. But the author says when we try to approximate continuous growth with discrete steps, we get that leftover error. That remainder they refuse to sweep under the rug. They call this error delta.
And instead of ignoring it, they say this error is the physical friction of reality.
Yes, it is the cost of taking a discrete step in a pixelated universe. The sources break this friction down mathematically into 3 parts: a linear cost, an imaginary phase shift, and an amplitude corrector.
Okay, stop right there. Imaginary phase shift. Imaginary like a math glitch, or imaginary like moving into another dimension.
The latter. In math, imaginary numbers correspond to a rotation, a shift into a perpendicular dimension.
Oh, okay.
The friction isn't just slowing things down, it is actively twisting the geometry. It's this very friction, the inability of a discrete step to perfectly map a smooth curve, that creates the rotational torque of the entire universe.
Wow. So the error isn't a bug, the error is the engine.
Precisely, the engine of reality. And to harness this engine, the author proposes a massive conceptual shift. We have to completely eliminate the absolute 0 point.
The dead coordinate of 0, 0 on a standard graph.
Yes. They replace it with a vertical z-axis. 0 is no longer a dead hole in the center of the paper where nothing exists.
What is it then?
It becomes a 3D pole, a dynamic pillar around which the entire mathematical world rotates. And by using the z-axis, the sources derive both e and pi purely from physical geometry.
I'm going to need you to walk me through the geometry of finding exponential growth without using an exponential function, because my brain is breaking a little bit.
It's actually a gorgeous mechanical fusion. First, pi is simple. It's the geometric ratio of a closed cycle, a circle's circumference divided by its diameter.
Okay, so it represents a closed rotation. Got it.
Right. Now, to find e, the unfolding growth, the source uses a simple right triangle.
Okay, I'm drawing a flat right triangle in my head.
Let the short vertical leg be a length of 1, and let the long horizontal base be a length of n.
Okay, so if I'm remembering the Pythagorean theorem correctly, it's a squared plus b squared equals c squared.
Right.
So 1 squared is 1 plus n squared. And the hypotenuse is the square root of n squared plus 1, which means the hypotenuse is just barely longer than the base n.
Exactly. Now, you take the ratio of that short vertical leg to the hypotenuse. You add it to 1, which represents a single, discrete step of base growth.
Following you so far.
Then you apply the scaling factor geometrically, n times.
So you take a starting line segment, and you multiply its lengths by that tiny ratio, and you just keep doing it, letting it compound.
You scale it up geometrically. And as n approaches infinity, the length of that final compounded segment becomes exactly Euler's number, e.
That is wild.
It's elegant, isn't it?
It really is. By swapping at the dead zero for a vertical z-axis pole, e and pi completely stop being these random, competing, infinite decimals. They're just two different visual angles of the exact same rotation.
Exactly. Pi is what happens when the mechanism closes a circle, and e is what happens when the mechanism scales outward.
They are deeply connected geometric realities. Geometry, algebra, and physics all fuse into one single, discrete, rotating mechanism around that central pole.
It forces us to question everything, whether the smooth calculus we've used for centuries is actually describing truth or just providing a low-energy approximation that masks the clicking, rotating gears underneath.
We have covered incredible ground here in this deep dive. I mean, we started with the speed of light, seeing how locking it in as an absolute god forces the rest of the universe to warp and break like a devil.
Right.
We moved down into the quantum foam and saw how counting with binary is structurally dead because it likes the internal spilling over tension of base 3.
And we killed the infinite geometric point.
We did. We replaced it with a honeycomb of vibrating phase shifts. And finally, we realized that the error in math is actually the torque of reality, spinning E and pi around a central dynamic pillar.
It is a total paradigm shift in how we structure knowledge.
And that leads to one final thought I want to leave you with, something to mull over long after you finish listening.
Oh, this is a good one.
We touched on this idea of replacing zero with a vertical z-axis pole and wrapping reality around it. But there is an implication hidden in these notes that we haven't explicitly stated yet.
The localization of infinity.
Yes. Classical math treats infinity like a straight line shooting off endlessly into the dark void. An unreachable distance.
Right.
But if reality is built on discrete phases rotating around a central pillar, then infinity isn't out there in the void. It's rolled up into a closed ring around that z-axis.
Which is mind-bending.
It is, because it raises a massive question. Does the universe actually stretch out forever? Or are we just walking in endless circles on the surface of a single, localized mathematical cylinder?
Next time you look up at the night sky,
ask yourself if you're looking at infinite space or just staring across the curve of a very vibrating, pixelated, finite cylinder.